All right. Thank you, Sandra. I think you've given us all a great deal to think about. And you mentioned autonomy, which is one of my 3 favorite words. And hopefully at the end of this, you'll understand why. So, within platform engineering at Deloitte Consulting, we help our customers perceive, react to, and ultimately embrace the disruption that's happening in every single industry on the planet. And we do that from a position of experience because we ourselves have gone through a similar change, a disruptive change in the way that we work and the way that we deliver solutions for our customers. And I'm going to describe that learning by experience that we've gone through over the last 5 years or so. But first, let me set the scene for how we operate and the types of challenges that are experienced by our customers. And I think this should all be fairly familiar to you because you all live this as well. Cloud, mobile, big data, devices, they're all driving very fundamental changes in the economics of the systems that we work with and the businesses that we operate. And this slide is kind of out of date already because there's no real mention of IoT, there's no real mention of machine learning and AI, there's no mention of robotic automation. These are the next things that are coming down the pipeline towards us to pull us out of our comfort zones. The reality is, for ourselves and our customers, we all need to be able to anticipate change and respond to that change faster than ever before. So we need to be able to move faster, enable innovation, always be transforming. So transformation is not just something you do and then you finish, it's something that we are always doing. And we need to be just as disruptive as the disruptors that come into our different marketplaces. So let me wind back to around about 5 or 6 years. Mark Andreessen, one of the inventors of the World Wide Web, and also a principal at Andreessen Horowitz, he wrote an article in the Wall Street Journal in 2012 about why software is eating the world. And he really succinctly put it when he said more and more major businesses and industries are being run on software and delivered as online services. What Andreessen said was that every company is now a software company, whether you like it or not. And this is on top of probably a 20-year legacy of many major enterprises around the world actually moving away from software. Banks thought of themselves as banks. Insurance companies were insurance companies. Utilities, they kept the power running. All of these companies felt that IT was often something that was risky and not part of their core business, and they would address that risk by removing the risk. They would try to outsource it, or they would try to offshore it. Let's get it away from our core business as far as possible. And this was exactly the wrong way to operate because, unbeknownst to them, the companies that would come in and change their business models, that would change their industries, were companies that think of themselves first as software companies. So now all of a sudden, our customers and ourselves are forced to think about being a software company first, delivering bank services, or a software company delivering energy, or a software company delivering logistics. We all know some familiar names, some familiar models that are coming in with these new software-centric attitudes and changing their enterprises. So the reality for all established businesses is that you cannot predict how your business will look in 5 years' time. You cannot predict who your competitors will be in 5 years' time. And you cannot predict the technologies that you will be using in 5 years' time. So in that sort of environment, in an unpredictable environment, your only logical response is to put yourself in a position where you can change when the unpredictable happens. It's all about change. Change is the byword of doing business in the modern era. But most organizations, certainly a lot of the ones we work with, they struggle with change. They struggle with change for a lot of different reasons. Some of it is their legacy systems architecture. Many of the systems that have been built up over the last 20 years were not designed with modularity in mind. So there's lots of dependencies. There's dependencies which make change difficult. If I go and change a system over here, the ripple effects out through my systems architecture can have unintended consequences in other places. So change is difficult from a technical perspective. Change is also difficult from a cultural perspective. Organizations are trying to become more agile. They're trying to insource the technology knowledge that they outsourced previously and perhaps lost that comfort and maturity with software and with technology. So organizations are changing their attitudes to change. They're changing their attitudes to risk, and they're willing to be more embracing of risk and software and technology. So this was the world as it kind of existed in that 2011, 2012 timeframe when we started to see these forces of change at work in our industry. And I'm going to talk about the journey that we went on through this process. First of all, cloud. As Sandra said, cloud is pretty much mainstream now. It's a given. Probably 5 or 6 years ago, it was important. It was obvious that it was going to be important, but it wasn't quite mainstream. We could see cloud becoming the new de facto way of deploying your systems, of managing your systems. Even if it wasn't public cloud, the techniques, the technologies, the automation, the abstraction around private cloud was incredibly beneficial for organizations that would embrace that. So cloud changed the way we built our systems, it changed the way we managed our systems, and it changed the way that we worked with our systems. All of a sudden, everything became distributed. Our technology infrastructure, whether you liked it or not, was a distributed infrastructure, and that meant distributed systems were important. That meant you needed to understand and be proficient at integration. It was no longer about just standing up a monolithic ERP and running your business on that. You needed to be proficient at integration. You need to be able to compose your infrastructure out of platform as a service, infrastructure as a service, software as a service. Composability became the key skill that you needed your IT organization to have. It also changed the technologies that we needed to work with. So just the fundamental protocol of the web, the protocols of the web became the important technologies. So cloud taught us that abstraction was important. We couldn't rely, or we couldn't take it for granted anymore that our systems would be in our data center, running on bare metal, that we managed, that we paid for, that we operated. We had to be able to live in a world that was hybrid, where services would be sourced and consumed from literally anywhere on the planet, from business partners, etc. It also taught us the benefits of automation. Automation was all about being able to spin up instances, being able to spin up capabilities within minutes and work with those. And that led to an incredible thing, which was autonomy. All of a sudden, our developers, with a swipe of a credit card in many cases, had the tools that they needed to make great things happen. And it's that autonomy that's been a huge part of the lessons that we've learned. Open source was another big lesson that we learned around that 2012 period. Now, open source has been around, it's been the crucible for innovation for decades. In the integration space, in the middleware space, we were still very much dominated by proprietary, vertically integrated products. We'd been through the service-oriented architecture wars. Everything was XPs, SOAP web services. These were vertically integrated, very expensive, very complex protocols and technologies that we were working with. And that necessitated big multi-year transformation projects. A lot of organizations were building these big multi-year ESB projects. This was the age of big SOA. But with the cloud coming down the horizon, we could see that that kind of infrastructure wasn't working. Just the protocols just wouldn't work. And the technologies that were driving those ESB projects weren't working either. So open source middleware became something that became a lot more tractable, a lot more relevant in the cloud world. And also, as I said, organizations were changing their attitude to innovation and to risk. They no longer outsourced risk. They brought it in, they embraced it, and they addressed it through incremental change. They would learn by doing, they would often learn by failing, and they were comfortable with that approach. So we now had smaller, more agile projects where you'd stand something up, you'd try it out for weeks or months. If it worked, great, you would scale it. If it didn't work, then you learnt a lesson and you changed your way of doing things. Proprietary technologies with big upfront license costs don't work in that kind of environment. That kind of environment demands an open source approach where I can mix and match, I can bring in the products that I need, I can try them out, and then when I need to scale, that's when I look for the support of a vendor, effectively. So open source was suited to this new agile incremental learning world, and proprietary software just didn't cut it in that sense. APIs were another lesson that we learned around that stage. So we were heavily invested in service-oriented architecture and ESBs, and we were delivering a lot of value to clients around those ESBs, building out reusable services. The lessons that we learned, things that worked, was the granularity of those services, the abstraction, the ability to deliver business value through reusable services. But there was some things missing. And one of the things missing was adoption. Okay? If you create a reusable service, you don't get the value out of that unless it is used and reused. And training developers up in SOAP protocols with proprietary technology stacks didn't gain the traction that was necessary to really realize the benefits of those services throughout an organization. And around that time, API infrastructure became fairly mature and popular. So API gateways, API portals, specification languages for RESTful services became more mature and more widespread. And this allowed us to really move away from the old SOAP proprietary protocols towards more open, more RESTful, more web-oriented ways of building these services. And that APIs really turned that model on its head. It no longer became about the ESB and the platform and you must use it. It became about developer engagement. So flipping that model on its head, developers were our customers, developers were the people that we needed to woo, and we needed to design and provide the services for our developers to use. So self-service became a very big thing. Put it out there, make APIs easy for developers to discover and to use, to find the documentation, to get an API key, to immediately start using the APIs. So self-service was a critical lesson for us, and self-service comes back to this idea of autonomy, okay? Give your developers the tools that they need, the access to the assets within your organization, and they can be productive, they can be innovative within their own agile teams. I think another important lesson for APIs was abstraction, the ability to provide these services as a business level of functionality, abstracted away from the underlying infrastructure, from the underlying technology, okay? We weren't able to, we could use APIs to remove a lot of that tight coupling that was in our legacy systems. It would allow us to mix and match and compose these capabilities, regardless of whether they came from our own internal data centers or whether we brought them in from external software as a service. So once again, APIs in the broader global spectrum led to that composability that organizations needed to be more agile in their delivery. One of the side effects of adopting more open source technologies was the ecosystem that came with it. And no longer did we have to rely on a vertically integrated stack. We could take advantage of the other tools that were being developed in the open source community. And a big one was continuous integration, continuous delivery capabilities. So things like Jenkins servers and you know, JUnit and all of those things that we take for granted these days. You know, Git source code control, etc. So we were introduced through open source to an automation ecology that became extremely beneficial. So we did a lot of work around learning how to be automated, how to git push your code, and that would kick off the build, the test, and ultimately the deployment into a UAT environment or a production environment. Automation was a huge benefit for the way we would deliver our services and our solutions. It created productivity, it created certainty. You could reduce your feedback loop so that you would rapidly discover any issues that existed and you could rapidly correct those issues as you found them. So automation, a key element to our journey. So we were fairly comfortable in that 2013 timeframe with our new open source middleware tools, with our agile approaches to development, and with our continuous delivery automation pipelines. Everything looked pretty cool, and that was the way we were going to work forever. But disruption happens. And one of the things that came along was containers. Well, we'd known about containers. We were used to them. We didn't really use them a lot because they were mainly operations concern. Extremely valuable in the data center, but for a developer, not so relevant. The big thing that happened in containers, and I'm sure you all are aware of this, was the Docker project that came along and added some new capabilities to containers. So the ability to define a container image with a file, the ability to inherit containers from each other through the use of a layered file system, the ability to access containers from a registry, whether that's an open registry or an enterprise registry, and the ability to have a single unified API for managing the life cycle of those containers. All of a sudden, containers went from being a systems concern to being a developer concern. Containers provided our developers with automation tools, with all of the tools that they needed to do their job well. It allowed them to wrap up their environment into something that was portable, and we could then hand that off to the operations people. Containers, in that respect, really helped to separate the concerns from developers and operations. Developers could take care of what's inside the container, and the operations people, well, they would just move the containers around and make sure that they were running and make sure that they were scheduled correctly. So once again, this is an autonomy. It allows the different parts of our organization, the different parts of our technology pipeline to concentrate on the things that they need to do well without having to worry about upstream or downstream consequences to a large extent. So we adopted containers by stealth, actually. We started working with containers and immediately found productivity benefits. So the ability to bake a solution, to bake what we would now call a microservice into a container image and then run that anywhere in the infrastructure, and to redeploy in the face of scale-up or scale-down requirements, in the face of DR requirements, to run those containers independent of the external environment was extremely liberating, extremely efficient, and it also greatly simplified our automation pipelines. So our CI/CD infrastructure that we'd lovingly created over the years became really simple and really easy to use because of containers. Okay. And as I said, we started by stealth and we started small. It was all very manual. We'd deploy containers with scripts. We would use a reverse proxy as our service discovery and routing tool. And that worked well for about 12 months or so. But as our projects and our use of containers started to get larger, we demanded, or we found the need to be more sophisticated in how we did our orchestration. So we started looking at orchestration tools like, Mesos and Docker Swarm and Kubernetes, etc. And we landed upon Kubernetes. We got some very smart people into our organization who helped us build our Kubernetes infrastructure, and we ended up building our own paths, which we ran for about a year or two, I guess. And it worked very well. We brought together Kubernetes and Docker, and we had our Jenkins pipelines, and we had our Elasticsearch analytics pipelines, etc. And we spent a lot of time and a lot of effort and a lot of pride and a lot of joy in building our own platform as a service. But eventually we discovered that that was really difficult. It's a lot of hard work, particularly in an environment like Kubernetes and Docker, which are changing on a monthly basis. When new versions come out and a lot of the features are changing because we're in that rapid innovation cycle, keeping all of these elements of our paths together and tested and socialized was extremely difficult and time-consuming for a small group like ours, and really it wasn't our core business. Okay, so after working with our own best-of-breed paths, we came back and had another look at OpenShift. Around that time, OpenShift version 3 came out, and OpenShift had adopted Kubernetes as the orchestrator. And we were really excited by that because we looked at our best-of-breed paths and we looked at OpenShift, and lo and behold, they were pretty much the same thing. So it was great minds thinking alike. And that's when we moved towards a mode where OpenShift is now our default platform for delivering our solutions to our customers. Somebody once said that history doesn't repeat, but it rhymes. And I think you can look back at where Red Hat had its genesis in the Linux ecosystem. Back in the 1990s and the early 2000s, there were lots of organizations that were excited by Linux, and they were building their own distros, and they would create their own best-of-breed Linux distros and use them internally, and experience those similar struggles of keeping these things tested and socialized and running. And I see a lot of organizations doing that now with Kubernetes. They're all jumping onto Kubernetes. They're building their own Franken-Pazes, and they're learning the lessons about how much hard work that is. And I can see that Red Hat is doing an awesome job right now, redoing what they did in the Linux world, 20 years ago, applying that knowledge and experience to the new platform. And we really see this as the new platform. I think to a large extent, the Java ecosystem has been the old platform. It's done really well in the last 20 years. Since 1998, the appearance of the first app servers, Java app servers, that's been the defining platform for our on-premise client-server world, enterprise world in the last 20 years. But the new world, the new cloud world, demands a new architecture. People are excited about microservices architectures. They're excited about polyglot languages. They're excited about being able to scale and compose their solutions across hybrid infrastructures. And that's what the new platform gives us. It gives us a way of abstracting away the underlying infrastructure, whether it's on-premise or on cloud or on the other cloud. By having that OpenShift layer in the middle there, we can operate in any environment. We can build and manage microservices architectures, and we and our customers can become genuine cloud natives. So out of that journey, a couple of the fundamental ingredients that I think we've discovered, which are the keys to success. One of them is abstraction. Abstraction away from the underlying infrastructure. Modularization is another way of thinking about abstraction. The ability to build our systems as modules, which can be composed and reused without that legacy coupling that many older architectures struggle with. Automation is a critical ingredient as well. Cloud wouldn't be possible without the underlying automation, and the way that we work and the way that we are effective and productive, and the way that we manage a lot of risk in the software development lifecycle is all through automation, through continuous delivery processes and those kinds of things. Ultimately, those things give our developers the tools and the knowledge and the permission that they need to do their job well. And that's really autonomy. So that's my favorite word, is autonomy. And ultimately, these three things together, abstraction, automation, autonomy, give you agility. I had to throw in a World Cup Messi picture, but I think Messi's out now, so it's all irrelevant. They've been disrupted too. Okay, but agility is the byword that we want to get. And I think I've just got a brief period left. We came up with kind of a platform manifesto. This is our series of, I guess, lessons learned or watchwords that we use around how we design and deliver systems. This is our platform manifesto. Really, self-service is another word for autonomy. Self-service and automated over manual processes. Open and extensible over closed and proprietary. Reusable, composable assets over point solutions. Iteration. No one really does well out of big bang deliveries. They're risky. You want to avoid them. Always be changing, always be iterating. We want loosely coupled teams over monolithic projects. We want sustainability and lightweight governance over cowboy solutions. I think Sandra talked about innovation silos. That's a lot of the problems with a lot of innovation projects is that they're carried out in silos. They're not brought into the core and leveraged to innovate the entire organization. So that's what integrated to the core is the last element there. Okay, thank you for your time.
Thanks, Saul. Thank you.